Today we're going to be looking at section 11.2, solving quadratic equations by using the quadratic formula. The quadratic formula, using the equation written in the form ax squared plus bx plus c, the solutions are x equals a negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. So that is the quadratic formula. On example 1, they want us to solve 3x squared plus 16x plus 5 equals 0. Well, 3 is A, 16 is B, and C is 5. So plugging that in the quadratic formula, we get a negative 16 plus or minus the square root of 16 squared minus 4 times 3 times 5, all divided by 2 times 3. A negative 16 plus or minus 256, and that's our 16 squared, minus 60 divided by 6. Continuing to simplify, 256 minus 60 is the square root of 196. The square root of 196 is a perfect square, and it's 14. So taking the top route, we have a negative 16 plus 14, all divided by 6. When we do the math, we get a negative 2 over 6, which we know reduces to a negative 1/3. Doing the bottom route, negative 16 minus 14, we find that it's a negative 30 over 6, which is simply a negative 5. So the two solutions to our equation is a negative 1/3 and negative 5. On example 2, we're asked to do the same thing. We're given the equation 2x squared minus 4x equals 3. We need to take the 3 over to the left side, so we end up with 2x squared minus 4x minus 3. In this example, a is 2, b is a negative 4, and c is a negative 3. So we have to be careful and carry those negatives with b and c. Plugging it into the formula then, we have a negative 4 plus or minus the square root of a negative 4 squared minus 4 times 2 minus 3, all divided by 2 times 2. Continuing to simplify, we find that it is 4 plus or minus the square root of 16 plus 24, all divided by 4. Well, we know 16 plus 24 is 40, and we also know 4 times 10 is 40. Well, 4 is a perfect root. It's 2 times 2, so we bring that 2 out, and we have 4 plus or minus 2 times the square root of 10 over 4. Well, we notice that 2 can go into 4, and it also goes into 2. So when we reduce it, we get x equals 2 plus or minus the square root of 10, all divided by 2. On example 3, we're given the equation 1/4 m squared minus m plus 1/2 equals 0. You certainly can use fractions if you want to, but I wanted to get rid of the fractions, so I multiplied by the common denominator of 4. When I take 4 times 1/4, I get m squared. Then when I take 4 times a negative m, I get negative 4m. And finally, 4 times our positive 1/2, we get plus 2. So now we know what A, B, and C are. We're going to plug them in the quadratic equation. So we have a negative 4 plus or minus the square root of negative 4 squared minus 4 times 1 times 2, all divided by 2 times 1. Continuing to simplify, we find that a negative 4 plus or minus the square root of 16 minus 8, all divided by 2 times 1. Well, we know a negative 4 is simply a positive 4, and that 16 minus 8 is 8. Continuing to simplify, we have 4 plus or minus 2 times the square root of 2, all divided by 2. Again, these all have a common factor of 2, so we can reduce it to 2 plus or minus the square root of 2. Going on to something new, it's the discriminant. The part of the quadratic equation under the radical is b squared minus 4ac. It's also known as the discriminant. It tells us how many and what type of solutions there are to the equation. If b squared minus 4ac is positive, there are 2 real solutions. If it is 0, there is 1 real solution. And finally, if it is negative, there are 2 complex, but not real solutions. Looking then at example 4, it asks us to use that discriminant to determine the number and types of solutions. We have m squared plus 2m plus 1, and we are looking at the discriminant. 2 squared minus 4 times 1 equals 0. Then the equation has 1 real solution. If we look at the equation 3x squared plus 2 equals 0, then 0 squared minus 4 times 3 times 2 gives us a negative 24. Then the equation has 2 complex, but not any real solutions. Lastly, we have 2x squared minus 7x minus 4 equals 0. Looking at the discriminant, we have a negative 7 squared minus 4 times 2 times a negative 4, and we get a positive 81. Since the discriminant is positive, it has 2 real solutions. On example 5, we have a nice little word problem. An object is thrown upward from the top of a 200-foot cliff with a velocity of 12 feet per second. If the height above the ground, and we're calling it h, in feet, and the object after t is seconds, it is h equals a negative 16t squared plus 12t plus 200. Well, how long then will it take to strike the ground? Well, we know at the ground it is a height of 0, so we plug in 0 for h, and we use the quadratic equation. But before I do that, I want to simplify it, and I'm going to divide this equation by a negative 4. And when I do that, I get 4t squared minus 3t minus 50. The only reason why I did that to just make it easier when I plugged it in. You certainly can use a negative 16 and 12 and 200, but in the end, you're just going to end up reducing. So I went ahead and did that up front. So now I have my A equaling 4, my B equaling a negative 3, my C is a negative 50. Plugging it in the quadratic equation, I get a negative 3 plus or minus the square root of a negative 3 squared minus 4 times a negative 50. All of that divided by 2 times 4. When we continue to simplify, we get 3 plus or minus the square root of 809, all divided by 8. So if we take the positive route and divide by 8, we get approximately 3.9 seconds. I won't even do the negative one because there's not such a thing as negative time. So the only root that makes sense is the top one, 3 plus the square root of 809, all divided by 8, which again is approximately 3.9 seconds.